Hey guys, welcome to Playable Workshop. This channel is dedicated to helping you make your very own video games. I'm Nick Glenn. I've been programming for over 20 years, and today I'm joined by Jack Sather.
Hey everybody, I'm a YouTuber and I love talking about video games and I've always wanted to make them. So hopefully through this Playable Workshop class, I'll be able to take on the role of the student and you'll be able to relate to my noobness when it comes to making games and being taught by Nick Glenn.
So throughout this series, we're going to be teaching you how to make games. We're going to teach you the concepts behind making games, including code. And what we're going to be trying to build throughout this series to teach those concepts is a
Heavily inspired.
pretty heavily inspired by the Legend of Zelda games that appeared on the Nintendo 64.
We chose Zelda because who doesn't love Zelda? But also Zelda, like something like Ocarina of Time, serves as a great jumping off point to get into other games, making games like Dark Souls or Skyrim or The Witcher 3. And hopefully with this class that we're teaching here on Playable, you guys will get the tools to make your own indie games and maybe one day make the next Skyrim. Or Zelda Ocarina of Time, because that's more applicable here.
So without further ado, let's get started. So the first thing we need is the game engine. It's the main tool we're going to be using.
And we're using Godot, which I've worked in. I don't want to sound like I don't know what it's called. Yeah, I've made like 4 videos using it. So we get the engine from Godot's website, godotengine.org, and we're going to hit the download latest button. And it gives us 2 options. Which option are we going to choose?
So we are picking the first option. .NET is just if you're going to use C#, which is a different programming language. We are going to use the language that comes with Godot called GDScript because it's simpler. Just pick the first one.
And you can use GDScript with the .NET version as well, right?
Yes.
But you can also use C#. And we're using 4.4, which just came out. So we're going to download a zip folder, which we can unzip with something like 7-zip, or I think Windows also has an unzipper now, or WinRAR if you're like me and stuck in the 1990s. Okay, so I'm going to hit extract here, and then we get a Godot.exe, and then also one that says console. We're going to use the not console one, right?
Correct. Yeah, you want to just use the standard .exe. Consoles for a whole different set of problems to solve.
We're going to open up Godot, and this is something that I love about Godot. We didn't install anything. It's just ready to go immediately, which is one of the coolest things I've seen with game engines specifically. Like if you're running Unreal and stuff, not talking trash here, but it takes a long time to start up. Godot is immediate. All right, now we're in Godot and the legend begins.
So this is our project splash screen. As you can see, Jack has some missing projects.
It's broken games, just bad attempts.
Broken, broken, gone, broken.
To create a project, we can use the create button in the top left there. And the only thing we really care about is the name and then where to save it on your computer. Everything else you should just leave as the defaults.
So what should we name this thing? Something like Zelda Wannabe.
If you don't want a creative name like Bajelda.
Zelda's good. Zelda Wannabe, real. And then it's trying to save in my OneDrive, which I've never used in my entire life, but Windows always wants me to. So I'm going to select this folder and then edit now. We're going to work on it right now. So let's get into it.
All right. Welcome to Game Dev.
Game development. We're officially in the Matrix.
We are seeing an empty scene. There's always a scene open in Godot, which is why when you first open it, you see this and there's, I guess, nothing here. And scenes are just basically collections of nodes, which we're going to get into in a minute because they're super important. Jack, I see you moving around already in our 3D viewport, that big center panel here.
It's because I've used Blender before.
Yeah. Why don't you explain how you're doing that?
Yeah, so there's like some simple controls. If you guys have worked in like 3D art software before or anything really 3D, the way I'm moving my camera around right now, rotating it, is just by holding down the middle mouse button, just like that, and then dragging around. You can zoom in and out with just the scroll wheel, or you can hit control and middle mouse click if you're an insane person. I mean, you're already at the middle mouse, but just scroll in and out. And then if you hold shift and then middle click and move around, you can move your camera like that, just called panning. And if you hold right click, you can kind of move your camera around like you're in a first person view. And Nick showed me something very cool, is if you use WASD while in this mode, you can move around like you're in a first person game. And then I think you can hit shift to have like you go super fast, like you're sprinting.
Yeah. And then Q and E can go up and down as well.
Some of you also might be wondering why there's certain colored lines across the screen. I'll let Nick explain what those are.
So these are called axes. Specifically, these are the global axes, right? So it's kind of like our baseline or starting point. Where all these lines intersect, that is what's called the world origin or world center. And that's going to be equivalent to 0, 0, 0. And this is going to be really important later on when we get into like programming. And if you want to know what these colors and these lines mean, they have names. They're the X, Y, and Z axes. these. And you can figure that out by looking in the top right corner there. There's a little widget.
And then you can also click on each one of these dots to kind of show the orthographic view, which just means like kind of like the flat view of those directions. The front view that it's kind of hard to show without like an object in the scene. To face forward again, that would be clicking on the Z that has the letter on it. We're back to the front. And then you can just, again, middle mouse click and move out of it. It'll kind of like snap out of it back to where we were. Get me in the game. Let me build something, Nick. We're taking too long.
So to start making our game, we got to start using those nodes I alluded to earlier. Nodes are the basic building blocks we're going to use to construct just about everything inside of Godot. Each node may have a parent, and if it has no parents, we typically call it the root node. This will usually be the node at the top of the list. And then each node can also have either 0 or more children. If it has 0 children, you'll often hear it referred to as a leaf node. We get these kind of terms of root and leaf from the fact that nodes are typically stored in a data structure called a tree, and this is why you're going to hear us call the scene tree a tree. Nodes also store data, which we call properties, and that's used to help drive the behavior of the node, which is just nerdy programmer speak for what the code doing. With that out of the way, let's start adding nodes to our scene. So we're going to look in the top left. There's a scene panel. We also call this our scene tree panel. There's a few different ways we can add nodes, but to get our first node, we're going to hit the 3D scene button, and that's going to add a very simple, very boring node 3D node.
Awesome. Starting off hot.
And we see nothing because this node, in a sense, does a lot, but in a sense does nothing at all. So to get something more interesting to work on, now that you're part of the industry, throw an industry term at you. Yeah. We're going to whitebox a level. And by level, I just mean a floor.
Exciting stuff. Stick with us, people. You won't regret it.
Whiteboxing is just a term used in the game industry to talk about the process of creating the most simple implementation of a level or surrounding game environment in order to test mechanics and see what works and what doesn't work. You don't want to spend a ton of time and resources on something that's not going to make it into the final game. Whiteboxing is kind of the remedy or solution to solve that. We're not actually doing a lot of whiteboxing in this series. We're going to give you some assets that you can just run wild with. They'll be a lot more entertaining than having to actually whitebox everything yourself. But since most of your games are going to start with the whiteboxing phase, we felt it was important to at least show you what that process looks like.
We're going to start simple just to show you like how you can put something into a game and have something move around real fast. Trust me, if you've never designed a game before, this is a cool feeling.
And if we don't do this, then you're going to be so lost.
Yeah. Also, if we don't cover the basics, you are going to be swimming in the deep end and drowning fast.
Whatever node is at the top of the list in a scene is that scene's root node. But we want to make sure we select that node, and then we can hit the plus button. So this brings up our node browser, which has all the different types of nodes available to us. And as Jack starts opening up drawers, you're going to quickly realize there's a lot of nodes that come with Godot, and this is where a lot of people get overwhelmed. The good news is you do not have to learn all these. You should not try to learn all these up front. Just learn the ones you need as you use them. Even in the various games I've now made and the games that Jack's worked on, we've used, 20% of these?
Yes, exactly. It seems to be the case in a lot of software. Something like, the Open RX hand. I don't think I'm ever going to use this, mainly because I don't think I'm making a VR game, but...
And also it's deprecated.
Yeah, and no one's going to be using it because it's deprecated. I've messed around with Godot now, so now I know that some colors are big indicators in Godot, like anything that's this blue is going to be a 2D node. Anything that's going to be green is going to be more of a UI element. And then the red nodes, or the kind of salmon color, if you want to get technical, are going to be your node 3D nodes. And this is what we're going to mainly use for our games because we're making 3D. We're blowing straight past 2D, baby. But there's a lot of nodes here. So do we want to search through all these things, or is there a simpler way to get to what we want?
The simpler way is going to be the big search box at the top of this browser.
Great.
What we want is some kind of a box that can operate as our floor. So why don't you just try typing box and see what comes up?
Box. Let's do this. Node 3D. CG, is this the one? CSG box 3D?
Yes. So CSG is Godot's kind of built-in prototyping white box tool set.
They just don't name it box because they want to weed out the weak, okay? Like if it was just as simple as box 3D, like they'd let anybody make games. CSG is, stands for computer science gizmo box 3D, and that's for technical nerds like us. But we got something. Yeah, it's a white box, and I guess it's kind of a blue box because it's selected, but Yes. So I know that the controls that we have here, we can move stuff around with just these little gizmos. And you might be wondering like why the box is blue. That's because we have it currently selected. Also, I just hit Control Z to undo that if anybody was wondering why it's just snapped back to where it was. We have certain modes selected, starting with the selection mode at the top of the toolbar here. And we're just gonna cover these 4 buttons real quick. We have the select mode, which is Q. So if I hit Q right now, I can click off the cube and we can see that it is a white box like Nick was talking about earlier. We're officially whiteboxing. So if I click back on this object in selection mode, next to Q, you have W, E, and R. Those are going to be how you can transform things quickly using the transform tools, the hotkeys. So you have W, where it has these arrows and you can move things around.
You can also hold control while moving it around to snap. And in this case, it's going to snap to points on the grid.
And we can head in any direction, the Z, the Y, up and down, left and right, X, undoing that. And then you also see that there's these little squares in between each one, and that is going to select both of them at once, moving in those directions together.
Another way to think of it is the color of the square is what axis it won't move on. So it's excluding that axis.
Oh, that's a good way to put that. So next we have the rotate, which brings up these spherical lines, which you can click and drag. Again, you can use control to have it snap to a certain degree. Is it like 10 or 15 or something?
Yeah, it's something like that.
And we can move around. And next we have the scale, which is much like the move, but now we actually stretch that object in those directions. And again, we can kind of hit those in between sections and move it freely like that. But if you hold shift, it'll kind of keep that equal setting that you have,
which we call uniform scaling.
Yep. So now that I have the power of all transform controls mastered, I'm just going to squash this down and move this out to make my floor.
You wish it was that easy.
This is not the right way.
And the reason for that is that right now we're squashing and stretching what is still ultimately just a cube. But what we want, and the reason we want this is because there could be some weirdness in the physics engine. What we actually want to do is change the true properties or the true size of the box. We don't want to just squish a box.
Gotcha. And this doesn't mess with the true size because if you look at the top right, even though we've seemed to squash and stretch this, it's still 111 across the board, which isn't what this looks like.
Right. And by the way, the thing that Jack just pointed out, this right-hand side is called the inspector panel, and it's going to show what are called the properties of anything you have selected on the left-hand side, like, the node or whatever, right? In fact, if you want to know what any of these properties do at any time, one quick way to do that is just hover over the label next to the property. This is going to give you the name of the property along with a little description of what the property does and what it's for.
So if these controls didn't change this, where is it being changed?
If you look in the inspector panel and go down the list, you're going to see a group called transform. And if you expand that group, we have position, rotation, and scale. And if you were to manipulate any of these controls, you'll notice that those numbers are now changing in the property in the inspector.
Gotcha.
We don't want to change it in the scale. We want to change the actual size. So to reset it, and you can use this on any property, we're going to hit the little recycle circle button, and that will set it back to its default. And we see we get a cube once again.
Perfect in every way.
Perfect in every way. So to change the actual size of the object, what we're going to do is go up towards the top where we have our size property. We can click into that first one there and type, say, 10. And suddenly we have a very long but very narrow floor. We could put 10 in the Z axis. That would be the last part of the property there. Or if you wanted to do this more organically, you could use these red dots that are showing up, the little red gizmos, and those will actually manipulate the size of the box. But here's the trick. If you don't hold Alt, it's going to actually just go in that one direction, and it's going to move where the center of the box is. So while you're moving with these little gizmos, make sure to hold the Alt key, and that'll then pull it out evenly.
I'm going to eyeball it to 10, but then I'm going to be anal and type 10 in here just to make sure it's perfect. And yes, I said anal in the tutorial. How's that for educational content? You can't censor me.
We have our floor, but it's, if this like grid we're seeing is kind of like the floor of the world, right? That's like 0 in terms of height. We want the top of this box, the top of our floor, to be the floor. What we should do is we should actually use the move controls now.
These ones, no dots.
Yep.
So I hit W. I'm going to bring this down. I imagine since we're using a 10, it's going to be like negative 0.5.
And the reason that works is that's just half of the Y size of our box, but downwards. Why don't we try playing our game? To do that, we can go to the top right, and we have a bunch of preview buttons. The first one's going to run our project as if someone was just booting up our game. So the first time you click this, because we haven't set what our like starting or main scene of our game is, it's going to make you pick one. So we'll just use the current scene we're working on, hit select current. And then because it has to be a saved scene, it's now presenting us an option to save the scene that we're working on right now.
Gotcha. Which folder are we in right now? What is res?
So res is actually our project folder. Wherever you saved your project on your computer, all of your game's assets, code, everything is going to go in this folder.
And what does that stand for?
Stands for resource or resources. Let's call the scene start.
Yep.
And then make sure to save it into a new folder called scenes.
Organization is important. I've learned this in game design. Just do it. Do we want to capitalize it? It doesn't matter. It's a folder.
It doesn't matter for folders.
Boom. And it is starting our game.
Yeah, it takes a second.
And there's nothing.
Nothing!
At least I think I'm saying nothing.
You're seeing nothing. So this gray is basically Godot telling us like, this is my default color. You haven't told me to show anything meaningful. To do that, we need to make something that's going to be our player's eyes and ears in the world, which we call a camera.
Okay.
So go ahead and select the root node and then hit the plus button.
And we're doing that because it'll become a child of the node 3D. It'll go in here as well.
Yes, you got it. And like I said, we're looking for a camera. So just type camera and let's see what pops up.
Camera 3D, red, salmon. And I can move this around with my gizmo.
You sure can.
And look at that. We get a camera preview at the top right corner now. So if I move up, it'll move up. Look at that. We are in the future, people. We're making a game.
All right. Why don't we go ahead and hit play again and see what our game looks like.
Watch the... Why?
This is a very fun gotcha for people jumping into Godot for the first time. The reason we're seeing nothing is there's no lights or lighting or anything in our game.
It's just camera and action. There's no lights. There's actually no action either. It's just camera.
So the reason we did not see what we see in the Godot editor here, essentially there's just some preview settings happening here, and we can toggle those on and off in the toolbar. They're the little light and globe icons. There you go. So if you turn those off, and now it looks just like the game did.
Boom.
If you're wondering now how we make our game look like our demo scene, the menu dots right there, yep, lets us edit the sun and preview environment. And at this point, if you want to like not see this, as Jack so lovingly puts it,
Poop brown and this dead gray sky, like the most depressing colors they could have chosen, which so many of these game engines show for some reason. Let's make something fun. Let's get like a sandy beach, blue skies. Let's come on. Let's see some smiles.
And you'll also notice that as he's editing these controls and the colors and everything, this is affecting what's called the ambient lighting of the scene.
So like lighting is affected on that square cube. Excuse me.
Yeah.
Okay.
All we're doing though is we're editing the preview settings. We still haven't added anything to our game level.
Great. It's still gray.
It's still gray. There's these two big buttons on the bottom. So one is going to add our sun or a directional light to the scene. And anytime you see directional light in 3D, that's basically a sun.
Yeah.
And then the add environment to scene is going to add an environment node, which has a bunch of different settings on it, one of which is our sky. So go ahead and do this for both of those.
And he's not wrong about the bunch of menus, because if you wanted to change your colors again, like let's say, because now if you hit this button, you can't customize it in the same menu. You're going to go to world environment. It's going to open up the inspector on the right. Now you're going to go inside the environment screen. Then you go to sky to affect the bottom half of the sky, the ground, or whatever we want to call it. Then you want to hit sky again. Then you're going to want to open up this procedural menu. And now we have options to go into the sky and the ground settings again, which are just affecting these top colors. So don't feel stupid if you lost where your environment settings were. It's easy to lose in this absolute haystack of a menu. Okay, so we've got the environment set up. Now if we hit play, it should be actually in our scene, in our game. Now we're gaming.
All right. So what do you want to do now with it?
I would love to make something that moves around.
Great. So to do that, we're going to need to add another node. This is
Okay.
going to be a very common practice if you haven't picked up on that already. What we're going to look for now is a character body 3D node. Pretty much every type of platformer, action game, first-person shooter, when you have a character or a player or something, you're going to probably start with this node to move them around.
Boom. Great. And We don't have anything. Again.
Yeah.
Which is kind of typical in game design stuff. There's a lot of things that involve building something, especially anything visual.
This node does a lot, but visually not. The purpose of this node is it integrates with the physics engine so that we can create a character that's going to like bump into walls or slide along the floor or whatever, right?
Yeah.
And if we look in the scene tree, we can actually see there's a little warning sign showing up. Why don't you go ahead and read that?
Node configuration warning. This node has no shape, so it can't collide or interact with other objects. Consider adding a collision shape 3D or collision polygon 3D as a child to define its shape.
We can just do what the box says.
So we're going to add a collision shape 3D?
Yes.
Add child node, collision shape, and there it is. Collision shape 3D.
Mm-hmm.
Create. And now we get another warning. A shape must be provided for collision shape 3D to function. Please create a shape resource for it. But this isn't saying make a new node. This is inside of collision shape 3D in the inspector where it says shape on the right-hand side.
This is probably worth bringing up, but every time you see a little box with empty or like a box with like boxes in it and that little drop down, this is a reference to some kind of a resource. So all these little options we're seeing here are just generating those resources directly on the object.
So do we want a box?
No, we want a capsule for a very specific reason, and I'll probably put some notes in the companion page. But basically, a box would get stuck on corners. A cylinder, yeah, it's round. It's not getting stuck on like corners of walls and stuff, but it's still getting it stuck on like floor or rocks or whatever. Whereas a capsule lets us have kind of a tall shape representing a player's body, but it can slide over things or up things or bumps in walls.
Again, this is just because like we're the player where we're gonna like feel that movement. But if you wanted to make a game object that was a cube, you would use a cube box to have it function like a box would in the real world.
Yeah, depending on what type of game you're making, right?
Yep. Okay, so I just moved it up. I'm gonna go ahead and move it back down. What should I do with this guy?
You should move it up.
Oh, move it up.
Yeah. We want the bottom of the capsule to be on the floor. And the reason for that is that it's going to be a lot easier later on when we start working on character movement stuff with code to think of where the character is or where the player is as wherever their feet are.
This was just affecting where the collision shape is. The character body is still in the same spot in that like kind of center origin spot that we had it at. But now if we move the character body around, we're kind of moving the shape up there instead of where it was before, where it was at like its center body, so it's not in the floor. So now we're kind of moving the whole thing.
You got it.
Those are good. That was difficult explaining. I was sweating through that.
So now if you were to try and play and be like, cool, I have a character body for the physics.
Here we go.
There's a whole lot of nothing.
Yeah.
And that's because the collision shape we added and the character body, this is all really for the physics system. We see it here because this is a dev tooling.
This for game developer eyes only. And this is between us.
In order to see our character, why don't we just reuse the CSG system again, and we'll just add something that can represent our player character here. So let's click on character body 3D. And we're gonna add another node and we can type CSG and see all the different CSG types. So you can do a box if you just want a box. Maybe you do a cylinder here. It doesn't really matter which shape you pick.
This is going to visually represent it.
Yeah, it's not going to affect the physics system.
So we're in the character body right now, but this is just affecting the shape. So I can drag this up and kind of match that capsule, I imagine.
I think if you hold control, you'll snap like from the center point. You'll snap right to the middle of your capsule.
Boom.
And then that'll make it easier to align it from there.
And the reason why it's not snapping to the capsule per se, it's snapping to the grid line that the capsule got moved up by. Like it just happens to be that same spot. And then let's make it bigger on the Y scale and kind of match that capsule, which like hits the floor. So that's about 1.95 meters.
If you wanted to be super exact, you could put 2. So that would be the height.
Is it?
The capsule's 2, right? So you could do 2 there as well.
Before we move around, again, just like the environment, I think this is a little boring. Can we change the colors of these guys, the floor and the object, the player?
Yes. So for that, we can look at the material property in the inspector. And right now it's empty, but you can click on it and it'll give you some options. And we're going to pick the first one, which is new standard material. We'll cover materials and shaders and all the other things going on here later.
You'll soon to come to find out that the word shader is a scary term to anybody getting into game design.
It can be.
Can be, yeah. So if I click this, this will expand this into a lot of other menus, which is a lot of things we're not going to use right now. We're just going to use one thing, and that is, what is this word?
Albedo. I don't know how you actually say it.
Also known as color. Why do they call it this? Some nerdy answer, I'm sure. I'm gonna make it a nice, sexy salmon, just like to really let them know that we're working in 3D. But right now, I'm like, what the heck? This is making a pink thing. And Nick pointed this out earlier. Why does it look pink, Nick?
The reason it looks pink is because when you select things in Godot, it kind of has that like blue highlight color.
So if I go to my Q selection mode, okay, there we go. So that's a little unhelpful while I'm looking at it, but it's my cross to bear. I'll just have to look at this. Well, I can actually change the object right here. Let's change it to a cube. Look at it a lot better. All right, let's make it that red. Let's see if that looks good. Woo! Crispy. Crispy like a red salmon. Now we're going to change the other box. So we're going to select this, the floor. And we're going to do the same thing. Get the material, use standard 3D, click this menu, albedo. And now what are we gonna make this? Let's make it grassy, which I can't really see in the game preview, but I can see here. I'm just blindly making it. Look at that, that looks great. That's a real game. Yeah, we'll just play it.
Let's play it.
It's already gonna work.
Let's see what happens.
All right, great, nothing. How do we get this thing moving?
Let's get this thing moving. To do that, we have to jump into the scary part of game dev for a lot of people, which is code. But I promise it's not scary. And it actually does become quite fun when you get comfortable with it.
And he's not just saying that as a guy that is an experienced programmer. Coding is really cool. Sure, it's intimidating, like looking at something that you don't understand in the beginning, but you'll be surprised at how quickly you can start to understand some of these concepts and terms just by being exposed to it over and over again. And Godot with GD script, in my opinion, has been the easiest way to start learning code for game design.
So what Jack said is 100% correct. And in fact, we're going to be using a template that Godot gives us that's going to really let us like jump forward a few steps and see that exciting moment of like, this feels like a game.
Yeah, yeah.
So we're going to right click on character body 3D. There's an option called attach script. And you'll notice that there's, a little icon with like a scroll and a plus. Yes, exactly. It matches those 2 points right there. So either of those buttons are going to do the same thing. At the top, we have our language selection. For us, it's just going to be GD script. Now, if you had downloaded the .NET version of Godot earlier, then you'd have GD script and C# as options here. Inherits is whatever node that we're going to be inheriting from or extending from, which we haven't talked about yet. The next thing down is going to be template. It starts like this by default. So if we just toggle this little use template checkbox on, we'll now see the available templates for whatever node type we have selected. Pretty much all nodes, because all nodes are a type of node, have the default template available to them.
Yeah, it's kind of rare that they have like a full built-out template for a node. It's kind of character body is one of the few.
We are going to use that because that's going to streamline us right to having a moving character.
Yep, like it even says it like what it is: template, basic movement, class movement for gravity games, aka most games, humanoid games, FPS, TPS.
And then built-in script, I don't really know what it does. It doesn't matter.
Which is rare for Nick, so that means it's really not important.
And then the next thing is path, and this is going to be where we're going to save our script. So let's go ahead and hit the folder icon there.
Because right now it's in scenes. We don't want it in scenes.
Yeah, we don't want it in scenes. We want to make a scripts folder.
Yeah, and so to get out of scenes, I'm going to hit this arrow, which takes us one back. This is the file system browser menu at the bottom left. So you can see like we were just in scenes down there, and now we go out one. We're at resources. So we're gonna make a new folder called scripts. This is where we'll keep our game scripts. And again, I can't tell you how important it is just to keep your stuff organized. It'll come in very handy. And we'll try to do our best here while we're running through this stuff. So are we gonna call this the player.gd?
Yeah, let's just call it player.gd. And by the way, a script is just a text file that happens to have code that has a certain extension on it. Player.gd for GD script. And that's it. Hit create.
All right, create. Oh. What is all this? Where am I? Where do we go? What happened to my game? Why am I in the Matrix? This also took us away from that game preview mode because we're now in the built-in script editor of Godot. A lot of game engines will usually have like an external script editor, which could be VS Code or Notepad, for crying out loud. Could it be? Whatever.
Oh yeah, no, that was the first 7 years of my programming life.
So crazy. Guy was born in the Stone Age. Anyway, so we're in the script menu right now, which, don't worry, your game's still there. It's just over in this 3D game menu. And then the 2D menu, we're going to be using for things like making UI and menus, health bars, all that kind of stuff. Back to the script menu. Nick, continue. This is where he's going to take over most of the thing because I totally know what I'm doing here and could explain it back and forwards, but Nick, go ahead.
We are going to be breaking this down piece by piece, but I think the best thing we could do right now is just let you play it and see what happens now that we created this little script file
Yeah.
that has some stuff in it, and we attached it to our character body.
Little scroll next to the character body. We're officially attached.
Yep, that means it's attached.
So let's hit play. Oh, and sunk to the floor. There's something moving on our screen, at least. Some good news.
Yeah. So one of the things the script added was gravity, which meant, we go down.
Get gravity. It's somewhere in there. Look at that. And it's just multiplied by delta, of course.
Well, of course, you have to multiply that by delta, strictly speaking.
Unless you want a computer with the turbo button, yes, you do.
I apologize to my nerds out there if I do nerd voice every now and then. I mean it with all love. Is the reason why we fell through the floor is because the cube that is our floor doesn't have a collision shape on it like our character body.
Yeah. It's not actually part of the physics system yet.
So if I were to go back here and go to CSG, I'm guessing on the fly here. If I were to go on this, click the plus button, add the child node, and look up a collision box again, collision shape 3D. This time I think we're safe to use a cube. It's gonna give me that warning. That's because I need to put a shape on it. We just did this, you guys know this. In fact, pause, see if you guys can do it yourself at home. We're back. All right. We're going to select a box shape from this menu. We can't really see it, but I think once we extend it out, we'll be able to see it. Let's do somewhere, 10 on each side?
What I would do, if you can't see the thing you're trying to size, we have a size property there, right? Just like our CSG box did.
Yep.
What we could do is just match our X and Y values.
Just 10 each?
Yeah, whatever you had it set to.
If we move it up, you can actually see that that is the collision box right there, but we're already perfectly aligned with it because it's inside of the CSG box, so its anchor point already makes it aligned.
And this is going to get into like relative orientations and
you're going to dissect relativity in front of these guys? What is this, Interstellar?
I mean, relative transforms is what I'm looking for.
Okay.
That's going to be a big thing later. Let's not worry about it too much right now.
I already crapped my pants in the script menu.
So you still have a warning on your collision shape.
Yes. Collision shape 3D only serves to provide a collision shape to a collision object 3D derived node. Nick, go ahead and translate.
Basically, this node needs to be under something that's talking to the physics system. So character body 3D is one of those, right? There's a couple other ones, one of which is a static body 3D. So if we wanted to go this route, we would have to add it underneath a static body 3D. Now, the easy way to do this is we can right click on this node.
Which, by the way, what you're saying is what is telling me to do. Please only use as a child of an area 3D, static body 3D, rigid body 3D, character body 3D, etc. So you just named static body 3D. That's what we're going to go for?
Because it's going to be a static body. It's not moving, right? It's not dynamic.
Should I make it a child node here, or should I click CSG box 3D?
So neither. Another approach you can do is you could right click on collision shape 3D and you'll see some options like we have reparent to new node. If we click that one, we can select the node and it'll automatically make it a child of that node and put that node where this node is.
Oh, so we're giving it the parent, like we're going 2 levels up. You will learn about the other types of body, rigid body, 3D object or nodes later. Boom. So that made that the parent of the collision shape. And now it's all happy.
Now, if you hit play,
we don't have controls yet, I think, because they might be the arrow keys. Yes, look at that. Video gaming.
We did it. That was a lot of work for our white box.
Kidding me? That was a piece of cake.
Imagine you had built a whole level. Are you going to want to go set up collision shapes for everything, especially if you have a bunch of complex shapes?
No. Yeah, like a bunch of rocks.
We can actually delete our static body 3D. Let's go ahead and collapse down material because we don't need to see its details. You see there's a property there called use collision. If we turn that on and we were to try playing our game again, let's see what happens.
Bam. We're still in business. Real quick, before I say anything else, you know this is like weird, like squarey bug?
Yeah, I'm seeing it.
What do you think that we could just fix that real quick? Like figure it out? Quick timeout. Me and Nick just noticed that there's like this weird pixel artifact problem that keeps happening. And we're going to fix this real quick. I actually think we already figured out the fix. If you're experiencing this, to fix this right now in Godot 4.4, which just came out, like give it some grace, okay?
Bugs happen,
Yeah.
people. You will have bugs in your game.
Yeah. Not being defensive. Close out of this, go to your project settings, and then you're going to go to the search bar, type in render, and go down in the rendering menu, go to rendering device. If you're using Windows, switch this from Vulkan to D3D12, DirectX 12.
And then after you've done that, you're going to hit save and restart.
Boom. Everything's fine. Yes, that definitely fixed it.
Okay, great.
Feels smoother too. Oh, buttery smooth. Let's go. We're back in business. Instead of using my arrow keys to move around, could we switch that to WASD real quick?
Yeah, that's going to be pretty easy to do. Let's go up to project settings. At the top, we have some tabs. So you have general, input map, localization. Input map's where we're heading because we're dealing with inputs. So one useful thing to know about is that in the existing code that Godot gave us, it has this function that we're going to modify that takes in a bunch of stuff, like UI left, UI right, whatever. Those are these input action names. They're not listed here, but we can see them if we click that show built-in actions button.
So basically it has some default controls for in-game stuff.
I don't want to mess with the UI controls necessarily right now because we may not want to change these up.
Yep.
So let's go ahead and just disable the built-in controls flag for now, and we're going to add our own specific for moving. In that add new action field, we're going to type move underscore left.
Our first underscore, by the way. Just want to point that out. It's a real coder move.
Took this long to get there. Huh?
Yeah.
And then we're going to hit the add button. And before we go and like customize this, let's just add the other directions we're going to need. So we're going to do move right and move forward and move backward. This is the name of the action. We got to add some things to map it to. So on the right hand side, we have that plus button. What's cool is by default, it's already listening for input. So if we just hit A for move left, it's going to find it in the menu and we can hit OK. And then just do the same for the other directions.
Move right, D, move forward, W, move backward, S.
Now, if you wanted to add controller support, and if you had the controller plugged in, you could flick the stick to the left and it would automatically set that up. Now, if you don't have a controller plugged in yet, and you still want to set that up because you're already here, for a controller's left joystick, we'd actually go to the joypad axes. So I'm pretty sure joypad axis 0 would be your left stick. It says that actually. Left stick, joystick 0 left. So for move left, you'd select that one, hit OK.
And then left stick down.
Perfect. All right, we got to do one more thing. We're going to go back to script. And then right here, we have UI left, UI right, UI up, and UI down. Those are all those default UI controls. Just change where it says UI underscore to move underscore. And a quick trick here is if you highlight all of the UI part like you just did, and you hit Control D.
Oh, cool. It'll find the next one. Sweet. So if I type in move now, boom.
Yep.
We just are typing our first code here, people. This is huge.
Simple as that.
And now we play it. My brother, W and S don't work.
So the reason for that is we have move forward and move back.
Yeah. Move up and down are forward and backward now. So we got to change those. Forward. And I'm using control but arrow keys to move words.
One pro tip from a developer who's been doing this a very long time.
There he goes.
The more comfortable you get with the keyboard, the much happier time you're going to have.
Yeah, I actually learned a lot of this stuff from Ali Abdul, like a productivity YouTuber. And he like went over all the keyboard shortcuts and it's like, it's a lifesaver. Okay, let's see. Boom, forward and backward. Let's see if I can move off this edge. See, that's what's nice about the capsule. It can kind of give some grace before you slip off the edge to your inevitable infinite doom. Okay, so now we can move around. This feels so good. It's so smooth. And we can even jump already, I'm noticing. But we kind of are in this like still shot camera. Can we get it to be on our character?
Yes. This is actually going to be extremely easy in this case.
Okay.
And we won't want to change it later when we have more of a robust camera system. All we need to do is drag our camera 3D node that we have here onto our character body. So that's going to make it a child of our character body 3D.
And will this work just like instantly like that?
Yeah, that should be it.
Look at that. We're already moved up. Can we get a little closer and like tilt it down a little bit maybe?
Yeah, that's just going to be as simple as selecting your camera 3D and then using the move controls to just bring it in.
That's we're moving it on the Z axis for our British listeners. Bring it up a little bit. I'm using this little preview finder to really lock it in. I'm gonna rotate it just a hair. Let's see what that looks like. Look at that. We have a person moving around. We are that much closer to building, what were we called it? Wannabe Zelda, Bajelda, whatever it was.
So I think this is a great stopping point for right now, because we don't want to overwhelm our wonderful viewers on episode 1.
Yeah, we hope you guys enjoyed it. Hopefully it was a little bit more fun than the typical tutorial. We also want to release this as a parted out series, and this will be part 1. And we really want to release it that way because we want to get your feedback and know how we are doing as far as teaching the class. If you guys have any advice on like stuff that we're missing or questions, let us know in the comments down below.
Or you can join our Discord. We're setting up a community in there for you guys to share what you're working on. If you get stuck on anything in this video or have feedback you want to talk with us about directly, we're in there.
It did take a bit of time to put this video together, but that was mainly just because I was making another video. So give us a few weeks to put out part 2. We're still trying to figure out the cadence of how we're going to be able to release this, but eventually you'll be able to watch it all together and be able to make our first game from start to finish. But thanks for watching, guys, and we'll see you in part 2.